Welcome, everyone. This is Steve Kilgore, Vice President of Field Technical Operations with WANdisco, here today to talk with you about our recently launched product, LiveData Migrator, which provides a simple automated mechanism to migrate big data workloads from Hadoop into cloud. Now, that could be public cloud of any of the major varieties. It could also be private cloud. So, to start off, just to give a little bit of context, we look at the process of movement into the cloud really as a three-phase process. The initial one, of course, being getting your data moved into the cloud. That's what we're going to focus on today, doing migration of cloud of data, again, being a LiveData Migrator. The second phase we look at as hybrid cloud. So really what we're going to focus on today is the movement of data, taking what you have presently, perhaps in an on-premise Hadoop cluster, and getting that up into the cloud. We're going to focus a little bit on some of the things that we bring to the table in terms of being able to keep moving data as you change data at the source so that it's automatically replicated up into the cloud. But then you may, once you've got your data there, or while you're in the process of moving some applications, you may have use cases that require you to be able to make changes to data at both endpoints, both on-prem and in the cloud, and have that data synchronized. That's our LiveData Plane product that would help you address that. And also multi-cloud, if you're pursuing a strategy where you want to have certain functionality, take advantage of best-of-breed tooling, for example. If there's one piece of functionality you would like to utilize in AWS, a different functionality in Azure, a third piece of functionality in Google, then we also have abilities to help facilitate that. So without further ado, we'll move on in to discuss LiveData Migrator and what it's about, which again is migration, the key thing being actively used Hadoop data. For context, really the first question that I ask when you're talking about what are the challenges of migrating data is if you're talking about a small and static set of data, as we show here in the lower left, that's a fairly easy problem to solve, right? It's just a matter of any of a number of approaches you could take if there's not a lot of data and that data is not changing. Now, if you're talking about a large volume of data in the upper left, but it's still a static data set, then it's still not a technically challenging problem so much as an exercise in being sure you've got either enough bandwidth or enough time in order to allow that data to be moved. When things get really interesting is when you're talking about moving data that is being actively changed while you're in the process of moving it, because then you've got to figure out how you're going to ensure that what you wind up with at the end of your migration is consistent with what you've got at your source. Now, if it's a small amount of data, you may be able to realistically say, okay, well, I'm going to freeze the data at the source while I make that movement. If you've got a large volume of data and it's rapidly changing, that's a much harder problem, and that's what LiveData Migrator is designed to help address. So we'll go into that in a little further detail. Again, focusing in on options for migrating large data sets, you can take a manual approach, do something scripted, or leveraging a standard tool like a DisCP. Again, if it's a static set of data, you may use a data transfer device, something like an AWS Snowball or a Microsoft Data Box. And the model there, of course, is they ship that physical device out to you. You connect it up in your data center, load your data onto it, disconnect it, ship it up to the cloud vendor, they receive it, connect it up in their data center, and then load the data up. Now, obviously, you're talking about physically moving devices around, so that's going to take typically a number of days in order for that to happen. Then you've got the challenges of, well, as soon as I unplugged that device in my data center, as soon as I finished copying data onto it, if I'm continuing to change data at my source, then what I'm going to wind up with is a stale copy. A common approach to that is to say, okay, well, we may use kind of a hybrid model to say, we're going to use that to move the bulk of the data, and then we're going to try and do some sort of manual process, something scripted to say, well, let's take everything, scan through everything that we've got that has changed since we made that copy, and then move it. Now that approach is fraught with challenges, because what happens if you have, for example, a network outage in the middle of one of your transfers? What if something, you have issues with getting the data uploaded either onto the bulk transfer device or from that device when it arrives at the destination? Also, if you're talking about a long amount of time, if you can't freeze the data at the source, then you've got the issue with the changes. If you do try to freeze the data at the source, you've impacted your business in terms of them not being able to continue normal processing that would update that data. And that's the most common scenario that we see. IT folks who are looking at initially trying to do the migration may say, well, to make the problem easier, I'll freeze that data at the source. When they go to the business users and propose that approach, a lot of times the answer is, for how long? Oh, well, we can't freeze it for that long. We've got to be able to actively keep the business running while we're moving. So those are the challenges. And trying to come up with a manual process or to build something yourself that addresses all of the edge cases there is challenging. So we've actually built LiveData Migrator in order to facilitate that. The key piece of differentiation here that I want to call out and that we'll focus on in the demo is the continuous replication of updates once the data has been moved. So if you select a data set and say, I'm going to migrate this data to the cloud, that's great. We copy the data over, but then the key part comes in that as changes are being made to the data at the source, we get notification of those changes, capture those updates, and propagate them to the target on a continuous and ongoing basis. So what that means is really going beyond just the initial phase of migration. You can leave this live for some period of time, saying that as I continue to utilize data on premise, I'm going to have that live updated in near real time, the best close to zero RTO and RPO as supported by your network connectivity, so that you can continue to make changes at the source and see those changes reflected at the target, again, in near real time. So that's what we're going to show you. The architecture is very straightforward. The key points: single pass migration. We're not having to go through multiple iterations. A lot of times, if you've got a large volume of data and it's changing rapidly, people will say, well, I'll take the approach of moving the initial chunk of data. Then what I'll do is I'll rerun my same process in order to capture everything that changed while I was in the process of making that initial copy. Nice approach that might work in theory, but if your data set is big enough so that it takes a long time to scan through it, and if it's changing rapidly enough, as is often the case with the most critical data sets, then what you find is that by going through that multiple scan approach, you will iteratively approach a consistent state of having all of your data at the target. But if it's big enough and changing fast enough, you'll approach it, but you might not ever actually get there. In addition, having to go through multiple scans, particularly if you're talking about petabytes of data, takes a long time just to do the scan through. So being able to do it in a single scan is really key, and then capturing the events, the updates that are happening, so that at the end of that process, you know what you've got is a copy at your target that matches what you started out with at your source. Okay, so with that, I'm going to go ahead and hand things over to Scott Gaspard on my team, who will show the demo.
Hi there, I'm Scott Gaspard. I'm a solutions architect with WANdisco. I'm going to demonstrate using WANdisco LiveData Migrator to migrate Hive ORC tables in my on-premises Hadoop cluster into ADLS Gen 2 storage. Then I'll use Databricks Autoloader to convert these into Delta Lake format, and I'll use Databricks to visualize the data as it's changing. So our environment is set up as this. We have a Hadoop cluster running Hive with ORC tables on premises, an ADLS Gen 2 storage account, and we've got WANdisco LiveData Migrator, which is installed on an edge node in our Hadoop cluster. And then we've got Databricks loader, which will, as you'll see, which will do some conversion of the data into Delta Lake format for us. So the data flow looks like this. On the left side here, this represents our on-premises Hadoop cluster running Hive. Hive makes updates into its underlying Hadoop storage, HDFS. LiveData Migrator sees that data and then migrates it into our ADLS Gen 2 storage account. From there, Databricks Autoloader sees those changes and then converts them into Delta Lake table format, whereby we can then visualize with a notebook in Databricks. So let's get started. All right. First thing I'm gonna do is show you my environment here. Again, I'm running Hadoop on premises. In this case, I'm running Cloudera 5.16.2. I've got my Hue editor set up to where I can make changes into my Hive data on premises. I've got an ADLS storage account and container here, and as you can see, it's relatively empty. No data sits in it yet. And then I've got WANdisco LiveData Migrator running, again, on an edge node of my cluster. And I've got that configured on the source side to automatically, and then on my target side, I've got that configured to talk to my ADLS2 storage account. And then finally, in Databricks, I've got a notebook set up with an autoloader set to run. And then this is where we'll do some visualization. As you can see right now, there is no data set in Databricks at all, but we'll address that here shortly. So the first thing I'm going to do is I'm going to create a database in my Hive environment. While that runs, when the database is complete, then I'll go ahead and create a table to store my data. Okay, once this database and this table is created and it's empty, has no data in it, the next thing I'll do is to go into LiveData Migrator and start a migration. And we'll do that here. All right, table is now created. And while that's working, I'll go ahead here in my LiveData Migrator and I'll create a migration rule. I'm just going to give it the path my Hive tables are stored, and I'm going to select auto start migration. As soon as this is complete, it'll automatically start. Okay, that's running. And we can see, we can go back to our cloud storage here, and I'll do a refresh. And here you'll see that LiveData Migrator has already created some metadata into our ADLS2 storage account. Just give it a moment for this to complete. We'll come back to that in a moment. In the meanwhile, I'll go ahead and start my autoloader job on Databricks. Stream is initializing here. Back to my ADLS storage, you can see how it's created a new directory called user, and this is exactly where we're user Hive warehouse. This will be our database that's already been migrated by LiveData Migrator. You can see here what we're looking at. So that's already in place with LiveData Migrator. Our data is live and it's being migrated now, and then Databricks is now looking inside that directory for any changes that are going to be made, and then it will go ahead and convert those. So let's go ahead and put some data into our database. we're just going to start by, and my customer database here is essentially, it holds information about customers according to city, state, zip code, and so forth. So the first thing I'm going to do is to put some data into my newly created table related to customer accounts in Washington. I'll execute that query now, that insert query.
So Scott, what you're doing here is you're loading data into the on-premise Hive, right? And then we're going to see that it's moved.
That is correct. Absolutely. Okay, we can come over to WANdisco and you'll see a spike here on LiveData Migrator indicating that data is actually being migrated by LiveData Migrator. And while it's being migrated, you'll see that activity will come back down. And now if we go back over into our Databricks side, we should be able to run a query here in our Databricks. And as you can see, the state Washington, which we just loaded on our on-premises Hive data, is now being successfully migrated over to ADLS Gen 2, and it's being ingested by Databricks and converted into Databricks Delta Lake format. And you can see here, we've got a visual representation of that data.
Okay, great. Thanks, Scott. So what you've seen there was LiveData Migrator being utilized to move data over and to continue to move data as it was continuing to be updated at the source. We leveraged Databricks there to give you a nice graphical representation of how the data was showing up as it moved across. So a good example, if you would like to try this out for yourself, this is a shot of the web page at www.WANdisco.com. You can see on the top right, there is a link to our free trial where you're able to download and try out the software for yourself. So please feel free to take advantage of that. It does support migration of data across multiple clouds. One other item to point out is if your choice of clouds does happen to be Microsoft Azure, we do have currently in private preview, in addition to the LiveData Migrator that you've seen here as part of this demo, we also offer an integrated service integrated directly into Microsoft Azure that allows you to utilize the underlying LiveData Migrator as a service to replicate your data over, and that is treated very much as an integrated Azure native service. So it would be billed as part of your Azure bill and so forth. A nice collaboration that we've done with Microsoft there. On the other hand, we do have the command line version that Scott showed you, and its UI, the non-integrated one, so you can use that for other clouds, or if you want a consistent operational experience, if you're moving some data into Microsoft, other data into Google, for example, then we can provide that using the platform that you've seen. So with that, thank you very much, and we will go ahead and wrap the session up. If you have questions, please do come by our virtual booth that will be staffed all day on both days of the conference. Thank you, everyone.